Now you guys have probably, I would guess, talked a little bit about some of these ideas before, maybe in elementary school. So environmental issues, or we saw how humans are impacting our environment, how humans are impacting the earth. So humans obviously have a big effect on the earth. And there are some reasons for that. So lots of different species can affect their environment. For example, like a beaver builds a dam and changes like a stream ecosystem into a pond ecosystem. It has some pretty important effects on the ecosystem. But no species change and alter the environment or affect ecosystems as much as humans do. And there's a couple reasons for that. One of them is that humans, we alter our environment. We change our environment more than any other species. We can bulldoze a forest. We can level land. We can build houses. We can irrigate dry areas. We can drain wet areas. We can alter the environment to a degree that no other species can. And the other important factor is that there are a lot of people on the earth. And so most of our environmental problems that we think about, if we think back on the history of human population on Earth, pollution and acid rain and global warming and species extinction were not really a big factor 300 or 400 years ago. And because there weren't as many people then, and also we didn't use as many resources. We didn't burn as many fuels as we do today. So what is the Earth's population? Do you guys know? Ballpark, Alex?
4 billion.
7 billion? Yeah, it's pretty close to that. So it's obviously always changing as people are born and people die. But it's growing, the world's population. And so you can check out, there's a little calculator that shows current world population. That's obviously an estimate, but about 7.6 billion people live on the earth.
Is that changing while people are being born?
It's not actual keeping track of that. But we know the birth rate of people in different countries, and so we can estimate sort of how the population is growing.
So someone just got born right now.
So yeah, people are born every single second. So the Earth's population is growing very rapidly, and the more people on Earth, the more stuff they need. They need more food, they need more water, they use more energy. And so using all of those things and providing for all of those people has impacts on the Earth and on ecosystems. If we were to look at a graph showing human populations, okay, so this shows, going back 10,000 years or so. For a long, and this is billions of people, for a very long time, there were far under 1 billion people on Earth, a couple 100 million. And you see throughout history, stayed pretty much at that level. See a little dip there, that was during the Black Death, the plague. Okay, that was a disease that affected people in the Middle Ages that killed a big chunk of the population of Europe. And so you see a little dip there. But then all of a sudden, we see this graph take this turn and start to rise drastically. Again, today we're up about here. So one question is, well, what happened?
People had a lot of...
Raise your hand. What changed here as we went on in time? Zach? You're right, and a couple specific things allowed the human population to grow at that level. Alex, do you know one of them? An important one is medicine. So, anyone have any idea what the most important medical breakthroughs were that allowed people to live longer, that increased the survival rate of people? Because, 300 or 400 years ago, the survival rate of children, the life expectancy of adults, is much lower than it is today. Kat?
Like, I don't know what the medicine is called, but like medicines against like measles and hay fever.
So vaccines.
Yeah.
Nobody today gets disease like polio or smallpox. Those diseases have been basically eradicated through vaccines. You guys don't get chickenpox. Not that that's a deadly disease. The vast majority of people don't get measles. So that's because of vaccines were developed. Antibiotics were developed, which help prevent infections that would normally be very dangerous. We can clear those up much better now because we have antibiotics. We now know about
Antidepressants.
microbes and germs cause disease. And we know that we have to have proper procedures during surgery and medicine. So there's lots of things, but the point is, population started to grow, and we call this exponential growth. It wasn't just growing at a constant rate, it was getting larger and larger very quickly. And like we said, all of those people need resources. And that's where a lot of our environmental issues can be traced back to. Because humans need resources from the earth. We call those natural resources. Raise your hand and tell me, what are some natural resources humans use from the earth? Ava?
Water.
Water. Alex Picat?
Air.
Air. Alex Rana?
Trees.
Trees. Christian?
Oil.
Oil. Food. Yeah, those are all things that we use. And as you get increasing human populations, you need more and more food and water and air and fuel and so forth. Now, there's two categories of natural resources that we talk about. Renewable and non-renewable. You've learned this probably, right?
Yeah.
So what does it mean if a resource is renewable? Christian?
Able to be restored.
Yeah, it's sort of restored continually. It doesn't get used up. It's replaced over time. So what are some examples of a renewable resource? Something that's replaced over time.
The gas pump. Natural gas in there.
So that's not renewable, that's non-renewable.
Wait, what's the renewable?
It comes back, it's replaced over time on its own.
So
Yes.
like water.
Yeah, water. The sun's energy, right? If you have like a solar powered calculator, like you're not using up the sun's energy, it's not like gonna be gone, it's constantly replaced. Wind, there's those huge wind turbines which generate electricity. When you put one of those up, it's not like, oh, if we put up too many, we're gonna use up all the wind, right? The wind is constantly gonna blow. So things like food that we can grow continually. Okay? Hydroelectric power, where we have a dam and moving water creates electricity. Solar power, wind power. These are resources, they don't get used up. On the other hand, we have non-renewable resources. These are resources that once you take them and use them, they're gone, pretty much forever. If you take and mine out of the earth some gold, for example, and use it, well, that gold is not going to be formed again. You're using it. It's gone. What is probably the most common non-renewable resource that humans use? Oil. Oil. We call it oil, natural gas, coal. What do we call those things? John? Fossil fuels. Those are fossil fuels. And so those are deposits in the ground that were formed millions and millions of years ago. And when you take some coal out of the ground and you burn it, it's not coming back. It's used up. It's not going to form again. It's a non-renewable resource. Minerals that we mine from the ground are also non-renewable resources. burning wood. So wood is considered renewable because if you harvest wood properly, you can harvest some trees and grow trees that replace it. And those are examples of renewable resources. So here are some examples. So you probably have seen these are becoming more and more common. These wind farms, these are called wind turbines. They're technically not a windmill, but lots of times people use that term. But as the wind blows, turns these huge blades of the turbine, and they generate electricity. So this is a way of getting electricity that is renewable. Used to be that most of our electrical energy came from burning coal in power plants, a non-renewable resource. New York State has a fair amount of renewable sources of electricity, and one of those is wind. You see them here, like if you drive south near like Waterville, you'll see them up on the ridge there. If you go north in like Turin, you might see them. You can see them like in the Herkimer area. You can see them off in the distance on the hill. So they're getting more and more common. Another renewable way of obtaining energy that's becoming more common are solar panels. Probably see them in maybe your neighborhood, around your house, maybe you have them in your house. But these are called photovoltaic cells. When the sun, they're the same sort of thing that's like on your calculator, it's a solar powered calculator. Works on the same principle. When sunlight or light hits it, that light is transformed into electricity that we can use. But again, this is renewable, where the sun's energy is not getting used up if you put some solar panels on your house. These are becoming more and more common. These are a newer version. So you know the car company Tesla, which makes electric cars, really nice ones. They also now make solar panels that go on your roof, and they look just like regular roof shingles almost. And they're really cool looking. Also dams, where we trap water and then allow the water to come through, can generate electricity. Geothermal energy uses energy from within the earth. But these are all renewable forms of energy. If we can get energy through these sources, we're not using things up. Also, they don't produce pollution. But you're not burning anything when you use wind power or when you use solar panels to generate electricity, as opposed to non-renewable resources in which digging coal out of the ground, pumping oil from deep within the ground, extracting natural gas. These are all non-renewable resources. When you take those things out of the ground, they're used up. But also, when you burn coal or oil or natural gas, what happens? When you burn
Pollution.
Pollution. Carbon dioxide is used. Other chemicals are used. And that leads to some of the problems we're about to talk about. So the more resources humans use, okay, the more impact we have on the Earth's ecosystem. So some of the things that we do to try to reduce our resource use, you've probably seen this: reduce, reuse, recycle. Limits how many resources we use. Reduce means basically just try to use less of something. Okay? Whether it's using less packaging, using a car less, walking more, riding a bike more, using more efficient appliances. Those are things that help us reduce our resource use. Also, reusable products and things are helpful. You know, using a mug instead of a paper cup. Using a water bottle that you bring back and forth every day to school rather than plastic disposable ones. Because every time you create a new plastic water bottle, you need to use more oil to create those plastic bottles. Whereas if you have a water bottle like this, okay, you keep refilling it and you don't need more resources to make a new one every time. So longer lasting products.
Yeah, Mr. Jones, actually clear one.
Yeah.
There are clear reusable water bottles. Recycling, even if you do have things that you need to get rid of, like those plastic water bottles you're drinking, if we recycle them, that also preserves resources because you are able to recycle and melt down some of that plastic or glass and make a new product
Did
with
you
it.
watch the video?
Not right now. All right, we're going to talk about a few specific environmental problems. And have you heard of acid rain?
No.
This is
Yeah.
It's
In a book.
It's
So,
upgraded crossbow.
All right, Alex.
Yes, it
Is
is.
there acid rain in Fortnite?
All right, guys, enough with Fortnite. So, acid rain, people have the wrong idea about something, even if you have heard about it. So, acid rain is when the rain that falls on a daily basis is slightly more acidic than it normally would be. So, when we say acidic, we're talking about a property of a liquid. So, just like you talk about the temperature of water, you can also talk about its acidity. It's measured on this scale called the pH scale. And on the pH scale, normal rain is a pH of about 5.6.
This is something like I do in my pool.
And yeah, so you might measure the pH of your pool.
Yeah.
Do you have like a little strip you put in there?
Oh, yeah.
That's pH paper. And it tells you the pH of your pool. What, do you know what you want your pool to be? What pH level? Okay, so 7 is like neutral. Normal rainwater, I don't know, maybe you find this, if you like help take care of your pool, if it rains a lot, does the pH go down, you know? Probably, because normal rainwater is about 5.6, but sometimes pollution in the air causes the pH to drop even lower, and it becomes more acidic. And that poses a problem for ecosystems. No. So when the rainwater becomes more acidic, it's not that it's gonna, when it rains on you, your skin's gonna burn. Okay, that's not how it works. Basically what happens is when this acidic rain and snow get into ecosystems, they damage them. A forest or a lake can only take so much of this acidic rain before it starts to affect the plants and animals that live there. And so the reason that this acid rain forms is because sulfur and nitrogen, usually in coal and oil and other fossil fuels, gets released into the air. So if you burn lots of coal in a power plant, that sulfur gets into the air, mixes with the water, and makes the rain acidic. And that could eventually lead to forests and lakes sort of dying off. There's some areas that are more sensitive than others. Some parts of the Adirondacks, for example, their soils cannot take much acidic precipitation. And so there are some lakes in the Adirondacks that have no life in them whatsoever because they've become too acidic because of this acid rain. This graph shows that a little bit. So the orangish areas show where acid rain is more of a problem. And where is it? Northeast, right around our area. And one of the reasons for this is that pollution that's produced travels. So if you have a big power plant burning a lot of coal and releasing pollution in the air, that pollution doesn't just stay around the power plant. It moves through air currents. In the United States, air currents go from west to east. So a lot of that pollution is transferred to the East Coast, which is our area. Now, you can see some examples of this. This is a forest that has been basically died off, many of the trees. But certain trees are more sensitive, like spruce trees. So spruce forest can be damaged by this acid rain. It affects buildings and so forth. So if you've ever like walked through a cemetery and you see the older gravestones, they're kind of white, and have you ever seen where like the letter, you can't even read the letters in them, they've been worn down so much? That's because they used to make those gravestones out of limestone, which interacts with acid rain. And so if acid rain's gotten worse, those gravestones have eroded away. Nowadays, they make them out of granite, which is not affected by acid rain in the same way. Statues and so forth. This is an interesting picture because this shows a picture. It's the same statue. This is 1908. You can see the features on the statue. And this is 1968. All of the features of that face have been eroded due to increasing levels of acid rain. Okay, so that's one type of environmental problem.
Replace graves? Or do they get
I don't know, they could, like relatives or family members might. Let's talk about one last issue, smog. Not like from the Hobbit, smog, the dragon, but smog. The word is a combination of two words, smoke and fog. And smog comes about from pollution in the air reacting with sunlight. Again, the burning of wood and fossil fuels releases pollution that can interact with sunlight in the air and forms a chemical that is toxic called smog. Smog can become a problem for people with asthma, allergies, emphysema. In some cities where smog is like a major issue, oftentimes in like the morning weather report, they'll tell you, the temperature, if it's going to rain, but they'll also tell you a smog index. Because if there's too much smog, you should not be outside exercising. You shouldn't go out for a run because you're going to inhale too much of this pollution and it could actually damage your lungs. A problem in big cities, lots of times cities where there's lots of cars. It's in New York, somewhat. Los Angeles has a really big smog problem because the city of Los Angeles is in like a valley, and so the smog settles there. And there are also a lot of cars, and people drive a lot in LA. This is Beijing, China. This is on a day when the smog was not present, and here's the day when it was, because the weather conditions will alter it. And so you can see, this is not fog, this is actual pollution. So this would be a day you certainly would not want to be outside exercising because of this pollution.
How long is this for?
It depends on the weather. Sometimes the weather keeps it all like close to the ground and it's dangerous. Other times the weather, winds and so forth might blow it away. So it kind of depends on a lot of different factors.
Is it okay if we just go outside, just like?
Yeah, like you could go out and just go to school or work, but sometimes people wear like a mask to help them.
Like that guy?
Yeah, so London in the 1950s had a really bad problem where because of the weather patterns, smog settled in the city and many people died from it. It was really bad.
When we went to Beijing, they were wearing like surgical masks.
Oh yeah.
Is that?
Not sometimes we do that just for disease prevention, but also it might have something to do with that as well. All right, we'll talk more about this tomorrow. Watch some of those videos tomorrow to talk about the rest of these.
Like it's